so logarithmic, and again, we're just going to call them log functions just for short. Basically, these are the inverse of everything we did on Friday, which was exponential functions. Okay, and if you've forgotten what it is for inverse, inverse is really pretty easy for this thing. You just switch the x and y. Okay, so here's what a log function, log equation looks like. Okay, so you got y equals log of x base b is one way you can say it. You can also say it's the log base b of x, and you can kind of say it either way. It doesn't really matter. But you just at some point in time you say it's base b. You can say log of x base b or log base b of x. Either one's fine. If you talk about a function, well, instead of y equals, we just put f of x equals. And then it looks the exact same thing after that. Okay. And again, either one of these two that you do, b is your base. Okay. And the big thing we're going to do today is we're going to take things that are in exponential form and rewrite them in log form, and then we're going to take stuff that's in log form and rewrite them in exponential form. The big thing with that one is that we're going to do it today, and you're going to be like, what? We're not really doing anything with it. No, we're not going to do a lot with it. Tomorrow, we're going to show you how to use your calculators on a lot of stuff, and then we're going to take the same things we did today, rewriting, and then we're going to use our calculators to then figure out what the answer is going to be. So today's kind of that. We're just making sure it should be the kind of easy day where we're just going to do some stuff and rewrite it, and then tomorrow we actually, show you how to do everything we're going to do for this thing. So tomorrow's going to be a lot of calculator stuff. Okay, so very first thing we're going to do, we're going to rewrite some problems in log form. So we're going to start with like b to the x equals y. Okay, so when you rewrite it, here's all you have to do. Again, you're going to put the word log in there. The b that's here is going to stay the same. It's going to stay at the bottom. And then all you have to do, again, this is where we do the inverse part up here where we switch x and y. So you just switch where the x and the y are. The b is like the exponent on the x. Now we put the y here, and then the x goes over there. Okay, so if you throw numbers in there, let's say we're doing 6 to the x equals 36. Okay, again, log goes there. The base over here is 6, so that will stay at the bottom. And again, all we're going to do is just switch these two numbers. We're going to put the 36 there and put the x there. All right, and again, they'll mix this thing up that it won't always, be exactly the same. So maybe we've got x to the fourth power equals 81. Okay, so again, we put the word log. In this case, it's x to the fourth power, so x is your base, so it'll just stay down here. And then again, just switch these two numbers. 81 goes there, the 4 goes there. Okay. And then the last couple ones here, just to throw at you. Maybe that you got 13 squared equals 169. Okay, 13 squared, so 13 is your base. That'll stay at the bottom. And again, just switch those two numbers. Okay, but the only thing that you've got to be a little bit careful of on some of these is that some of the problems we've got, question. Some of the questions that we've got here, they'll mix up the order of the numbers that you have. So they may have like 1 equals 3 to the 0 power. Okay, so if you have one like that, this is where you almost have to kind of look at it a little bit different. You've got 3 to the 0 power, so your base is 3. And then you've got to switch, since the 3 and the 0 are connected, that's where you got to kind of switch these two things up. The 0 is not connected with the 3 anymore. Now the 0 needs to be over here, and then the 1 would go there. So if it helps, you can always take this one and rewrite it like that, so you've got your exponent first. So you can always just take this thing, this expression you've got, you can always just rearrange it, put the exponent part first with the base here, and then that way then you can put the base there and then switch those two numbers. That's about the only thing they can do to kind of throw you off in that case, is where if you get used to the exponents being over here, they put the exponent here, just rewrite it so it looks like that, and it makes an easy switch. Okay, everybody okay with that so far? Nothing hard on that one, right? Just put the word log in, the base stays on the bottom, and then you just switch your other two numbers that you got there. Okay, now if that's easy, here comes the even easier part to me. That if they ask you to take something and rewrite it in the exponential form. So it says the log of 125 base 5 equals x. Or again, some people say it's log base 5 of 125 equals x. Again, it doesn't matter to me which way you say it. All right, here's why this one's almost even easier to me. If they ask you to take it, rewrite in the exponential form, you basically get rid of the log part that's here. The 5 stays the same. It stays the base that's here. And again, you go back and switch these two numbers. So the log, the x goes up here, and then 125 goes there. So if you rewrite an exponential form, again, take the word log off, the base stays on the bottom, and then you just switch up those two numbers, and that's all you got to do. So if you got log base x of 7 equals 4, again, the x stays on the bottom. And again, for the other two parts, after you cover the word log, you just switch these two numbers. The 4 goes up here, 7 goes down there. So it should be just that easy if you go through those. So it's not, and again, not anything hard, nothing superly tricky on this one. The closest thing they have to a trick question basically would be this. Where you have log of x equals 12. And somebody says, where's the base, right? So there's not one. So if you get a problem like this, if there is no base, then the base equals 10. Okay, and there'll be a few problems. Actually, there'll probably be more than a few. There'll be quite a few problems where there will not be a base on it. So if you see something that doesn't have the base on it, then again, you just take that exact same problem and just know that if it's written that way, just put a base 10 there. Okay, and then you can turn around and rewrite it from there. 10 is your base, so that will stay there. And again, just switch those two numbers so it's 10 to the 12th power equals x. Okay, let me show you one more of those with something they might ask you to do today. Um, all right, so let's say we've got log base 4 of x equals 2. All right, so if we rewrite it in exponential form, that makes it 4 squared equals x. One thing they might ask you to do on some of these, and if not, this is where we'll go tomorrow. If you get to the end on this one, they may tell you, all right, if you can simplify x, tell me what the answer is. So what is 4 squared? What's 4 times 4? 16, right? So in that case, they may ask you to go ahead and give me a number. Now, that one, we wouldn't ask you to do 10 to the 12th power. That's something. That's a trillion, something big. I don't know. It's a bunch of stuff. That one, they probably wouldn't ask you to do. But something like that, where it's kind of small, where it's just 4 squared. So if you got x equals 4 squared, they may tell you, all right, if you can do that in your head, do it in your head. Tell me what the answer is. Now, obviously, on this one, you could write a 1 and 12 zeros behind it, but nobody wants to do that. I mean, that's just, there's no fun in doing that one. So that would be it. Okay, so there you go. So that's the two things we're going to do today. The big thing, going from log to exponential or exponential to log, kind of going back and forth. Um, we need to look at graphs on those. Show you one quick graph of these, and then after the graphs, we've got two formulas we got to look at. And once we get those two formulas, then we're good to go here. So. Okay, so what we're going to do for the graphs of the log functions is we're going to show you, go back and kind of flash back real quick to what it was for exponential functions and show you how to change those. Okay, I'm going to do this one in pencil, kind of do it kind of lightly so you can see this one. So before we get to log functions, if we did exponential functions, and if you weren't here on Friday, again, we'll kind of show you what it was. Basically, this was the graph of every exponential function that we were going to do, as long as it was growth anyway. So any kind of growth exponential function looked something like that. The big thing was for exponential functions that this number was going to be at 0, 1. Okay, but we said that for these, for doing log functions, we're going to switch x and y. So now we're going to do this. So instead of being at the point 0, 1, we're going to switch x and y. Now we're going to be at the point 1, 0. Okay, instead of getting close to the y-axis here, now we're going to get close to the x-axis. And how this thing would chase up on the exponent side of over here, we kind of chased up, kind of ran beside the y-axis. Now we're going to kind of chase up and run beside the x-axis. So that's the graph we did Friday. This is the graph we're going to do today. So again, 1, 0 is here. This is the log base b of x. And again, we're going to kind of stick with the growth part on this one. That the base is going to be bigger than 1. So domain and range. For this one, we went infinity to infinity for domain. So again, now that goes into the range. And the domain, now it's going to be from 0 to infinity. Because basically we're starting at 0 and going this way. So now the x values, we start at 0 and then we head off that direction. Okay. And then one other thing we're going to add in there, that we had a horizontal asymptote going this way. Well, now we're going to have a vertical asymptote going this way. So that's our cutoff line. Okay, so again, we flip-flopped everything. We had a asymptote on the x-axis. Now we got one on the y-axis. You know, this graph got close to the x-axis. Now it's getting close to the y-axis. We were at 0, 1. Now we're at 1, 0. So we've just turned the whole thing around x's and y's to get everything there. Okay, so what we're going to do, and again, you're not going to have to do like tons of graphs. It's mostly just kind of having a basic idea on this one. We're going to show you what happens if we change this graph a little bit, kind of how to move it around. And then once we do that, we got one more graph for this one, and then we'll show you the two formulas, and then that should kind of get us where we need to be. So everybody good there? Anybody still writing that part down? All right, so for this one, let's graph y equals log base 2 x minus 5 plus 3. Oh, one other thing you might want to put for this one. Forgot to do this for me. Remember for everything on here that you're going to kind of 1, 0 is your starting point now. So you can't see that. Sorry, my bad. So before we were saying instead of 0, 0, for this one, everything kind of starts at 1, 0. So that point right there is where we're going to start with everything. So when we start doing these graphs for log functions, everything starts at 1, 0, and then we're going to move it up, down, left, right from there. Okay. All right, so here we go. Here's where we're going to graph this one. And again, it's not a super detailed graph. You don't have to plot in points. You just do a quick sketch of it so we can see what's happening with it. Okay, and again, here's what we need for this one. Which way does the 5 and the 3 move this thing? 5 spaces to the, there we go. 5 to the right. 3 on the outside, that's your up or down. So 3 up, there we go. So we know we're just going to take this graph we've got here, and we're going to move it 5 spaces to the right, 3 spaces up. And again, you don't start at 0, 0. You actually start at 1, 0. So you got to start here, and we're going to go 1, 2, 3, 4, 5 spaces to the right side. And then we're going to go up 1, 2, 3, and that's the dot we're going to have right there. Okay. Now, and how you kind of get the curve on this one. We know it's going to curve and do something like this. But this thing back here, we had a asymptote that was at 0. If we move it 5 spaces to the right side, now we got an asymptote that's going to be right here at 5. So we're going to draw a line. That's going to cut off at x equals 5. So whatever this inside number is that's here, if you just change that sign, that's going to tell you that's your cutoff line now. Because again, we were at 0. We moved it 5 spaces to the right side. So now we got a cutoff line here. So when this thing starts moving down this way, it's going to get close to that side right there. Okay, so graphing these, that's all I'm going to ask for. You're not going to have to plug in, all these other things, all this other stuff. It's just just give me a basic shape. Just know which way, up, down, left, right, we're going. The one thing that I might ask you to do is domain range. Okay, and for these, it's going to be negative infinity. This part never changes. The only one that changes will be your domain. Because again, in this case, we scooted it left and right. So now that part's going to change. So it starting at 0. This is going to start at 5. So whatever this thing is here, this asymptote that's here, that's the first number that's going to go there. Again, that first number is always this number on the inside. Just change it from negative to positive, or if it's positive, you change it from positive to negative. Okay, so there's your graphs. And again, that's all you have to do. You don't have to do a whole lot with them. You're not going to have to plot x-intercepts and y-intercepts, all this stuff. It's just take this shape that's here and just move it up, down, left, right. And that's all you got to do. Just move this thing around. Okay, and then 2 formulas. This is the one that we should have had on Friday, but we cut it short because it's Friday. We're going to pick it back up today. Okay, so if I ask you to do exponential growth or decay formula, and you can use this for all kinds of stuff. Most of the time it's talking about money. They may throw some, mode spores, or they may throw some other stuff. Anyway, if they talk about exponential growth or decay, this is what we're looking at. So, okay, so it doesn't really matter what it is that they're going to throw at you. It's always pretty much the same thing. That it's capital A of t equals little a of t, and then 1 plus r to the t power. Okay, little a is the starting amount. The r is a rate. Only thing on that one, though, you have to change it to a decimal. So they'll give it to you as 4% or 10% or whatever percentage. You just got to change that to a decimal, and then t is time. Usually it's in years. Sometimes they might give it to you otherwise, but pretty much on that one, it'll pretty much be in years. Okay, and then the a of t, that's your amount after t time. Okay. Bad news is these are going to be word problems. The good news is these are going to be easy word problems because everything is going to be there for you. You don't really have to look for it. It's just going to be here it is, and just work through it a little bit. Okay, so it may look something like this. Again, we're going to stick with money just because money is usually the easy thing to do here. If you have $7,000 to invest for 20 years at 4%, how much money do you have? Okay, and this turns into a calculator question because again, it's not the formulas we've got. This first one, and we'll look at a second one here in a second. They're all pretty much just plug them straight in. There's not anything weird you have to do with these, so it's just knowing how to use your calculator and just plugging it straight in to everything that's here. So for this problem, Your A is 7,000. Time is 20. And your rate is 4%. And again, the only thing with that rate is you have to change that to a decimal. So that would be 0.04. Just got to move it over 2 decimal places. Okay, so then we're going to take those numbers, plug it back in up here, and then we're just going to use the calculator. The A of T, that's just the A of 20, which means after 20 years, we're going to have $7,000 times 1 plus, again, not percent, we got to change the decimal, so 0.04 raised to the 20th power. So there's our formula there. There's we just take the numbers and plug it back in. And again, this will be a lot quicker because you won't have to write everything down. Once you see the word problem, it's probably, 15, maybe 20 seconds at the most it's going to take on that one. And that's just taking your time and punching everything in. And when you punch it in, you don't have to do any little weird steps. It's pretty much just a straight plug it in and let the calculator do the work. So we got $7,000. You got your parentheses, 1 plus 0.04. Close off your parentheses and then just hit your power so you raise it to the 20th power. There you go. 15,337. Now, the only thing with this one, it is money. So you're going to go 2 decimal places. You got 0.86. It's either going to stay 86 or bump it up to 87. The next number is 2. So it will not bump it up. It'll just stay at 86. So 15,337. And then 86. Again, that's the amount after 20 years. So that technically is A of 20 equals that. But, there we go. Okay, so again, not anything hard. It's just a plug it straight in the calculator and then work it out. Here's the one last formula we need, which is this one's even shorter than this formula because it's got a lot of the same stuff that's here. We're still going to have the interest rate, still going to have the time, we're still going to have this amount we have at the end. It's just going to look a little bit different for this formula. I'll pause for a second, let everybody catch up there. Okay, last formula of the day, last little piece here. Okay, so the other one was growth or decay, and sometimes they call this like a payment plan where you do so many payments after so much time. You can do that one. Here's the big thing on this one. It has to say, they have to tell you that it's continuous. So that as soon as they say that, you'll know exactly that you've got to use this formula. And this is the formula you're going to use. Just the PERT formula. Because it spells out PERT when you plug in the numbers on. Okay, and it uses some of the same things back here. The capital A, that's still your amount after time. The R is still your rate. The T is still your time. The only thing that's different is in this case, P is your principal, which is your starting money. So the other formula back here, this could be money. This could be growth. This could be spores of bacteria. If you're in science, it could be it could be anything you want it to be. This one, it's always just money. So no matter what you do for this one, it's always going to be money. Again, R is your rate as a decimal, and T is time. All right, somebody's asking, what about E? I know that's what somebody's thinking. We talked about other stuff. On your calculator, if you look behind the LN button, there's an E that's back here. That's it right there. If you're on the Casio calculators. Oh, and also, notice the log button here. So when we start doing a lot of stuff tomorrow, we're going to use that log button because it says log there. If you're doing the Casios, the log button is over here on the right side this time. There's the LN and there's the E right above it. So the E and the LN buttons are always kind of together for this one. If you can find LN, the E button usually is behind it. So if you've got to get E in this case, you just hit Shift and then the LN button, and there's your E. If you're on the Texas Instruments, you're going to hit your second button, and then you're going to hit the LN button to get your E there. So that's the E that we're using for this thing, and that's where it is. So if you can find the LNs, the E button's always usually back behind it there. Some different calculators may have it somewhere else, but that's most of the time the E and the LN are always kind of together. Okay, so here's what it's going to tell you. Go for a smaller amount this time. Let's say you have $2,000 to invest for 6 years at 5% compounded continuously. How much money will you have? Okay. And again, it's a word problem, but it's an easy word problem because you've got everything you need. I don't think they get real tricky on these. All right, so the P is 2,000. Your time is 6 years, and your rate is 5%. Again, as a decimal, that's 0.05. Okay. And again, just plug it in. And again, you don't really even have to write this down. You're just plugging those numbers in. I'm just writing it down so we can see it here. So we've got 2,000. Again, the E button is the E button. There's nothing you can do with it. And then it's 0.05 times 6. Again, it turns into a can you use your calculator kind of a question. That you've got all the numbers there, just plug it straight in the calculator. This one, again, got to clear that out now. So it's just 2,000. And you don't even have to put the times, you can just put 2,000 E, and then you've got 0.05 times 6. And that's the only thing that might throw you off is that you've got to do the R times the T, depending on how it's set up. But in this case, you can just put parentheses, and as long as you got it there, just put 0.05 times 6, hit enter, and there you go, 26.99. Okay, and again, it comes down to can we round it or not? Here's how we round it off. Again, you got to go 2 decimal places. So we know it's 71. The 7 in that case will bump it up to 72 because it's bigger than 5. Okay, and if you're on the Casios, basically looks the same thing. We've got 2,000. Get your E button, and then 0.05 times 6. There you go, same answer.